Show an arrangement of three resistors, each of resistance 10 ohm, so that the combination has a resistance of 15 ohm. Give justification for your answer. This question carries 2 marks. Three resistors are given. We can try 4 types of arrangements to get equivalent resistance 15 ohm. First arrangement. All three resistors are in parallel. In a parallel connection, the equivalent resistance is always smaller than the smallest resistor. Here, all resistors are 10 ohm. So the smallest is 10 ohm, but the required equivalent resistance is 15 ohm, which is greater than 10 ohm. Therefore, this arrangement is not possible. Second arrangement. All three resistors are in series. In a series connection, the equivalent resistance is always greater than the highest resistor. Since all three resistors are 10 ohm, the highest value is also 10 ohm, and 15 ohm seems possible. But when we calculate three 10 ohm resistors in series, we get Rs is equal to 10 plus 10 plus 10 is equal to 30 ohm. So this arrangement also cannot give 15 ohm. Third arrangement. Two resistors are in series and the other one resistor is in parallel. If two 10 ohm resistors are connected in series, their total resistance is 20 ohm. So here 20 ohm and 10 ohm resistors are connected in parallel. In a parallel connection, the equivalent resistance is always smaller than the smallest resistor. Here the smallest resistor is 10 ohm, but the required equivalent resistance is 15 ohm, which is greater than 10 ohm. Therefore, this arrangement is also not possible. Fourth arrangement. Two resistors are in parallel and one in series. When two 10 ohm resistors are connected in parallel, the equivalent resistance 1 by Rp is equal to 1 by R1 plus 1 by R2. After substituting the values and after calculation, we will get 1 by 5. So Rp is 5 ohm. So here the equivalent resistance becomes 5 ohm. Then if we connect the remaining 10 ohm resistor in series with this 5 ohm resistor. In series connection, equivalent resistance Rs is equal to Rp plus R3. That is 5 plus 10. It is equal to 15 ohm, which is the required value. Therefore, the only possible arrangement to obtain an equivalent resistance of 15 ohm is two resistors in parallel and one resistor in series. Justification. Arrange two 10 ohm resistors are in parallel and then connected the third 10 ohm resistor in series with this parallel combination. This gives a total resistance or equivalent resistance 15 ohm. A battery of 6 volt is connected with a series combination of 5 resistors of 0.1 ohm, 0.2 ohm, 0.3 ohm, 0.4 ohm and 0.5 ohm. How much current would flow through the 0.3 ohm resistor? Justify your answer. This question carries 2 marks. Here, 5 resistors are connected in series. The equivalent resistance of this entire circuit Rs is equal to R1 plus R2 plus R3 plus R4 plus R5. After substituting the values, we will get 1.5 ohm. Now we can find the current flow through the entire circuit. Here we have a 6-volt battery. According to Ohm's law, V is equal to IR. So I is equal to V by RS. Substitute the values. V is 6 and RS is 1.5. After calculating, we will get 4 ampere. Here we need to find the current flow through the 3 ohm resistor. When resistors are connected in series, same current flows through each resistor. When resistors are connected in parallel, different currents flow through each resistor. When resistors are connected in series, different voltage is applied across each resistor. When resistors are connected in parallel, the same voltage is applied across each resistor. Here, these all resistors are connected in series. The current flows in the entire circuit is 4 ampere. The current flows through 0.3 ohm resistor is also 4 ampere. Justification. Same current flows in each resistor when resistors are connected in series. Determine the total resistance of the parallel combination of 3 resistances of 2 ohm, 4 ohm and 6 ohm. Here we want to find the equivalent resistance of 2 ohm, 4 ohm and 6 ohm resistors. They are connected in parallel. This question carries 1 mark. In parallel connection, 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Substitute the values, then we will get 1 by 2 plus 1 by 4 plus 1 by 6. After calculating, we will get 11 by 12. So the equivalent resistance Rp is equal to 12 by 11. After calculating 12 by 11, we will get 1.09 ohm. So here equivalent resistance in this parallel connection is 1.09 ohm. Use Ohm's law to determine the potential difference across the 6 ohm resistor in the following circuit when key is closed. This is 2 mark question. The equivalent resistance of these 3 resistors Rs is equal to R1 plus R2 plus R3. Substitute the values. Then after calculation we will get 12 ohm. Now we can find the current flow through the entire circuit. According to Ohm's law, V is equal to IR. I is equal to V by R. Here R is Rs, the equivalent resistance. Substitute the values, we will get 6 by 12. After calculation, we will get 0.5 ampere. So current flow through this entire circuit is 0.5 ampere. Potential difference, that is voltage across the entire circuit, is 6 volt and current is 0.5 ampere. Now we need to find the potential difference across 6 ohm resistor. According to Ohm's law, V is equal to IR. Here R is R2, that is 6 ohm. In series connection, the same current flows through each resistor. So the current flows in 6 ohm resistor is 0.5 ampere. So here I is equal to 0.5 and R2 is equal to 6 ohm. Substitute the values, then we will get 3 volt.